Fundamental forces in nature. In macroscopic world, there are two basic types of forces which are gravitational forces, electromagnetic forces. However, in microscopic world, there are two more types of forces. Strong nuclear forces, weak nuclear forces. So, there are four types of forces in macroscopic and microscopic world listed below. Gravitational forces, electromagnetic forces, strong nuclear forces, weak nuclear forces. Gravitational forces. Gravitational force was discovered by Isaac Newton. According to Newton, every body in this universe attracts another body, and the force of attraction between these two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. If there are two bodies of masses m1 and m2 at a distance, then according to Newton's gravitational law, the force of attraction F will be F is directly proportional to m1, m2, and F is inversely proportional to r square, or F is directly proportional to m1, m2 upon r square, or F equals G m1 m2 upon r square, where G is a proportionality constant called Newton's universal gravitational constant. Its value is 6.67 into 10 raised to the power minus 11 Newton meters square per kilogram square. G is called universal because its value remains the same everywhere in the universe. Characteristics of gravitational forces. These are always attractive. These are the weakest forces in nature. These are central forces, that is, they act along the line joining the centers of two bodies. Gravitational force obeys inverse square law, that is, it varies inversely as the square of distance between two bodies. Gravitational forces are conservative forces. The concept of gravitational forces depends on the field particle called gravitation. Electromagnetic forces. The force of attraction or repulsion between two charged bodies is known as electromagnetic force. If the interactive particles have same charges, force between them is repulsive. And if the interactive particles have opposite charges, force between them is one of attraction. The magnitude of electromagnetic force between two charged particles Q1 and Q2 separated by a distance r is given by F equals 1 upon 4 pi epsilon naught Q1 Q2 upon r square, where 1 upon 4 pi epsilon naught is a constant. Its value is 9 into 10 to the power 9 Newton meters square per centimeter square. Characteristics of electromagnetic force. These are attractive as well as repulsive forces. These are central forces. These obey inverse square law. These are conservative forces. These are raised to the power 36 times greater than gravitational forces. These are produced due to the exchange of a particle called photon, which carries no charge and has zero rest mass. Strong nuclear forces. The force which is responsible for the binding of neutrons and protons together in a nucleus is called strong nuclear force. It acts between two protons or two neutrons or a proton and neutron only when they are very close, 10 raised to the power minus 15 meter to each other. Characteristics of strong nuclear forces. These forces are only attractive in nature. These are short-range forces, that is, are effective only when the distances between the particles is of the order of 10 raised to the power minus 15 meter size of nucleus. Nuclear forces do not depend on the charge on the nucleons. Nuclear forces do not obey inverse square law. These are not central forces. These are non-conservative forces. These are 10 raised to the power 36 times stronger than gravitational forces, 10 raised to the power 2 times stronger than electrostatic forces, and 10 raised to the power 13 times stronger than weak forces. The weak nuclear forces. The force between the elementary particles emitted during radioactive decay of a radioactive substance is called weak nuclear force. In beta decay, electrons and neutron, that is uncharged particles, are emitted. The force between an electron and a neutrino is known as weak nuclear force. Characteristics of weak nuclear force. These forces appear only in certain nuclear processes such as beta decay of a nucleus. These forces are 10 raised to the power 25 times stronger than the gravitational forces. The other properties of weak forces are yet under investigation. Each fundamental force is thought to arise from exchange of its characteristic particles. The quanta of that force, as they are sometimes called. Electromagnetic force is caused by the exchange of photons. The strong nuclear force arises from the exchange of mesons, and weak nuclear interaction are caused by the so-called vector bosons, W plus minus and Z. The interaction with their exchange particles is shown in the following figures. Unification of forces. A lot of progress has been made in recent decades towards the unification of different theories and domains of physics. Some of them are as follows. In 1687, Newton unified terrestrial and celestial domains under a common law of gravitation. Oersted and Faraday showed that electric and magnetic phenomena are inseparable. Maxwell unified electricity, magnetism and optics, showing that light is an electromagnetic wave. Abdus Salam and associates showed that the weak nuclear force and the electromagnetic force could be viewed as different aspects of a single electroweak force.